In today's video, we're going to be talking about sleep. Good sleep is the critical foundation for so many elements of our lives. From our health to our cognition, it's hard to count the number of benefits that result from good sleep and the number of side effects that result from poor sleep. In today's video, we will discuss how our circadian rhythm actually works and how we can use that knowledge to fall asleep faster, sleep better, and wake up feeling rested. So, what determines the quality of our sleep and how refreshed we feel in the morning? There are two main factors to this. The first is a neurochemical called adenosine. Adenosine is one of the neurochemicals responsible for making us feel tired. The longer we're awake, the more adenosine builds up, and the more tired we feel. The reason caffeine makes us feel awake is because caffeine actually blocks adenosine receptors. The second factor that governs our quality of sleep is a cycle known as the circadian rhythm. A lot of people are familiar with this term, but they don't realize how important it is. Inside all of us is a kind of 24-hour clock that tells us when we should be awake and when we should be asleep. For the purpose of this video, we are going to use a blue line to represent sleep and a red line to represent wakefulness. For the most part, we tend to get all of our sleep at one time. And precisely when this period of sleep takes place in our 24-hour day and night cycle is determined by a couple different factors. The most powerful of these factors is light exposure, particularly sunlight. It's very natural for humans to wake up around sunrise. Adenosine levels are low at this time, and your system releases cortisol and epinephrine to wake you up. It's very important that this release in cortisol happens early in the waking part of your day. This release of cortisol is how your body knows when morning is. The release of cortisol and epinephrine in our bodies triggers a 12 to 14 hour timer that starts ticking in your brain. When this timer ends, your pineal gland releases melatonin, essentially telling your body it's time to sleep. This is how our bodies tell what time of day it is. In the morning, you get an increase in cortisol. This sets off the timer, and when the timer ends, your body knows it's nighttime. These cortisol and melatonin cycles are always active within us, but precisely when they fall in our 24-hour cycle is determined by external inputs. The most powerful of these inputs, by far, is light. In our eyes, we actually have a set of brain neurons. These neurons do not receive light information for the purpose of seeing, but specifically for the purpose of detecting sunlight. These cells are called retinal ganglion cells, and when they detect a specific combination of yellow and blue light waves that are characteristic of a sunrise, they communicate this information to an internal clock in our brains. This tells our brain that it's morning, and that triggers the release of cortisol and epinephrine. It's vitally important that we get light communicated to this internal clock in order to properly set our cortisol and consequentially our melatonin release. There are several studies that show how mismanagement of this cycle can lead to negative effects on learning, depression, metabolism, cardiovascular health, dementia, etc. There are many negative side effects to getting this cycle wrong. So let's talk about how we can get it right. When we wake up and open our eyes need light to trigger the release of cortisol. Without light, we can't trigger our internal clock. But not just any light works. Specifically, we need sunlight. Looking at your phone or turning on a lamp will not sufficiently trigger our morning pulse of cortisol. What the neurons in our eyes respond best to is the type of light that comes from the sun when it's low in the sky. The specific mixture of yellow and blue light that comes from the sun when it's low in the sky is what triggers this internal clock in our brains. By the time the sun is overhead, the quality of light reaching us has changed, and it won't trigger the rise in cortisol as effectively. Timing our rise in cortisol earlier in the day and earlier in your wakefulness cycle has drastic effects on depression and anxiety. So, how much sunlight do you need? How long you need to be outside is primarily determined by the brightness of the sun. On a cloudy day, it might take 10 to 15 minutes to sufficiently time your internal clock. On a sunny day, however, it might only take 3 or 4. I should note that you should never look directly at the sun. Sunlight is bright enough that just being outside in general is okay. These mechanisms in our eyes are not about seeing the sun, but getting certain wavelengths of light in your eyes. This function of our brain is incredibly important because it dictates what time we fall asleep and how well we sleep. So getting sunlight in our eyes early in the day is one of the crucial ways we can help set our circadian rhythm. But there are also some things to avoid. Early in the day, the neurons in our eyes that communicate light information to the internal clock are not very sensitive, so it takes a very bright light, like sunlight, to trigger the daytime signal. But as the day goes on, these cells actually get more and more sensitive. So by the time it's nighttime, very small or dim lights can actually trigger our daytime signal. This confuses our mind and can throw off our circadian rhythms. Before things like lamps and iPhones were invented, the only time we really got light in our eyes was during the day. Millions of years of evolution geared the human mind towards waking up with the sunrise and falling asleep at sunset. Nowadays, this isn't always the case. Because of screens and artificial lights, we are constantly confusing our brains with false signals of when it's daytime, when it's nighttime. Getting light in our eyes late at night phase delays our circadian rhythm and makes us think it's daytime when it's not. This can make it incredibly hard, in general, for us to fall asleep. But there are some ways to combat this. Turning down lights and wearing blue light glasses late at night can help reduce the daytime signals reaching your eyes. Keep in mind that blue light is one of the wavelengths we need early in the day to set our cortisol release, so you only want to wear blue light glasses later in the day or before bed. So essentially, we want as much light exposure as we can get early in the day and as little as possible later in the day. It's crucially important that we don't get bright light in our eyes between the hours of 11 p.m. and 4 a.m. A study by scientists showed that light exposure between 11 p.m. and 4 a.m. can negatively affect the release of dopamine and activate a part of our brain responsible for the feeling of disappointment. Managing late-night light exposure can have a dramatic impact on our mood and our mental health. Everyone's lifestyle is different, and I'm not telling you to wake up or go to sleep at any specific time. But implementing the practices we discussed in this video can drastically improve the quality of your sleep. And whether you wake up early or late, one of the most important factors in improving your sleep is going to bed at the same time every day. This will give your circadian rhythm something consistent to hold on to, and it will make it much easier for you to fall asleep when you need to and wake up feeling refreshed. So, for a quick recap, make sure you get sunlight in your eyes immediately after waking up, stay away from bright lights at night, and make sure you go to bed and wake up at roughly the same time every day. Implementing these changes to your sleep can drastically improve the quality of your health and your life. So there you have it, the neuroscience behind sleep and the circadian rhythm. Let us know your thoughts in the comments. Have a great day, and as always, keep learning.